Hey people, so the long-awaited video on polynomial equality. Polynomial equality is simply the concept that two polynomials are equal if, and you can copy this down, so this should be a section on polynomial equality. Two polynomials are equal if the degree of the polynomial is the same, of the polynomials are equal and the coefficients are equal. Okay? That's all you really need to know. That makes an equal polynomial. Now, why do we even care about that? Well, if you have questions like the below, find values for a, b, and c given the following are true for all x plus 1 times by ax squared plus bx plus c equals x cubed plus 5x squared plus 6x plus 2. Now, if we use the concept of polynomial equality, we're actually able to find these values in here. Now, you might look at that and go, well, maybe a equals 5. Maybe b equals 6. Don't be tricked. What you've got to do is expand this side out so that you get x squared and x cubed and x squared and x and 2, because we're saying these two polynomials are equal, so they must have the same degree, therefore they must be of degree 3, because remember the degree of the polynomial is the power that the highest power that the variable is raised to. So in this case the degree of the polynomial is 3. So we've got to expand this out because we don't have an x cubed term yet. So let's expand this. I'll do a, you can do b for homework. So we go x plus 1 outside of ax squared plus bx plus c. So that's going to just equal, remember we did this last lesson, that's actually the same as ax squared plus bx plus c, x outside of that, plus 1 outside of ax squared plus bx plus c. Alright, now if you're wondering where everything comes from, well, that x is that x, and that 1 is that 1. Yeah? So that x plus 1 has just been split up because that actually means the same thing. And now we can just expand that out. We did a bit of this in class. You'll get ax squared plus, did I make a mistake? Yes, I did. It's ax cubed because it's x squared by x plus bx squared plus cx plus, now 1 times ax squared plus bx plus c. Alright, now we can collect like terms. So we're going to put all the ax cubed terms, the x cubed terms together. Well, there's only one. Then let's put all the x squared. So that's bx squared plus ax squared. Alright. Then we're doing all the x terms, cx plus bx. And we're going to go plus c. I hope you're copying this as we go because I'm going to start rubbing in a minute. So, where did everything come from? Well, this bx squared term went together with this ax squared term. This cx term went together with this bx term to form cx plus bx. And the c stayed on its own and the x cubed stayed on its own. So now, as you can probably see, what we can do is factorize those a little bit. So we get ax cubed plus, now I'm going to take the x squared out. X squared outside of b plus a, you'll see why in a minute, b plus a plus, I'm going to take the x out from this one and that one, plus x, outside of c plus b plus c. Oh, I'm running out of room. Alright. Okay, so that's as far as I've got now. Hope you've got all that down because I'm going to erase some of this out. You keep writing in a straight line. I'm going to go back up the top. All right. I'm going to erase everything though. Just some. All right. So now if we look at this down here, that's an x, by the way. If it doesn't look like an x, it's an x. That's an x. So if we look at this down here now, do we have an x cubed term? Yes. Do we have an x squared term? Yes. Do we have an x term? Yes. And do we have a constant term? Yes. All right, so now we've got equal polynomials. We did before, but now we've written in the form so we can really see it's equal because the degree of the polynomials are the same. And what's the second rule for equality? The coefficients have to be the same. So that tells us something about all these values in here. All right, let's look at it. X cubed plus 5x squared plus 6x plus 2 is going to be equal to ax cubed plus x squared outside of b plus a plus x outside of c plus b plus c. Now remember, I'm going to rub that all down the bottom now. Remember that a, b, c, they're all just numbers. So if you go b plus a, you're just going to get a number. All right? So now, can we equate stuff? Well, what's the coefficient in front of x cubed? Nothing. Not 0, it's 1. All right? If you've got ever got no coefficient, it means it's 1. If it was 0, it wouldn't exist. So therefore, a equals 1. Yeah, that one, same as that one, both in front of the x cubed term. All right, let's go on to the next one. Well, 5 must equal b plus a. Why? Because 5 is the coefficient of the x squared term, and b plus a is the coefficient of the x squared term. Now we've already got the value for a, don't we? A equals 1, so 5 equals b plus 1. Let's take 1. B equals 4. So we've got a, we've got b. Now we could use this and find c plus b, but I'm lazy. I can just go straight to here and go c is the constant term and 2 is the constant term. So therefore c equals 2. And I found it. All right, pretty simple, hey? So you have a go at question 1b or have a rewatch if that was a little bit, didn't quite make sense, and see how you